Now let's take a closer look at LiDAR data, which once again, I'm assuming that you've already read about LiDAR data and already have a good understanding of it from the readings and from the ArcGIS help files. So these are .las files, and so these are very, very large files. And so often what will happen is when you import or bring in LAS data sets into a GIS or into ArcGIS, because there are so many points, what will happen is you'll have these boxes. So what it is it kind of says, okay, the points are there, but if you zoom in, you can find the points for each of these individual boxes. So for example, this particular box here is this one in this particular quadrant of campus. And so these are, like I said, massive files. And so what I did was I just essentially combined them all into one extremely massive particular file here. Now, there's a lot of things we can do with a LiDAR data set. Some of those things we'll touch on in the exercise and in later parts of this module, but there's a lot of stuff that I won't be able to cover. And that's stuff that you'll find in our remote sensing course or advanced remote sensing here at IUPUI. But LiDAR data, it's extremely cutting edge, but also it's something that you're going to see more and more usage of, especially as we get more into 3D modeling. And I'll show you what I mean by that later on here when I use LiDAR data to create triangulated irregular networks. So what I will do is we'll zoom into Kavanaugh Hall and take a look at LiDAR data and how it's different than other types of vector style data in which we see, in this case, points, but these are a huge number of points created, but also at different elevations or different z values. I'll show you what I mean here. Here is Kavanaugh Hall. We've got the quad over here, we've got the dining hall, we've got the campus center right here, and then the cancer center across the street. And so campus center and then the tube that connects Kavanaugh Hall with the campus center. Now if I go ahead and I'll insert the LiDAR data, and essentially what we have is we have individual dots, but we've got a ton of them. Look at all those individual points. And so we're talking millions and millions of individual points. And as we see here, of course, we have that same color pattern in which dark blues represent lower elevations and yellow represents higher elevations. And so now, unlike the other one, the digital elevation model, which really didn't do a good job of showing buildings, you couldn't really see Kavanaugh Hall, the vector data model and the isoline, the contour line map, didn't really do a good job of showing the buildings, but this LiDAR does a great job of showing the buildings. You can see essentially the perimeter of Kavanaugh Hall, the footprint, quite easily. In fact, you can even see the tube that connects the campus center to Kavanaugh Hall. Further, you can also see the trees, and so we're talking the level of detail is extremely high. So one of the things is, in terms of we zoomed in, this is in terms of this data set. This is just 40% of the actual dots, the actual data points. That once again shows the sheer size, the massive amount of data points that are collected when a LiDAR scan is done. Even further, if I right-click on this particular file here, and I have these different filters, I can do different points. I can do the ones that are from what we'll classify as ground. So essentially the ones that hit the bottom of the surface. The ones that aren't, the ones that are the last to return. Then I can also do the first return, essentially the top ones, the top. And so this is just different ways in which we can use, in this case, LiDAR data to look at different elevations, different z values in terms of where that data was recorded. Those that are recorded at the actual ground, those are kind of the last points recorded, and then the first ones, the first places, the first parts of the surface that are touched when that LiDAR is beamed down from whatever aerial vehicle is above. And so once again, we see elevation change. I'll just kind of compare this to the other data models once again. So let's click off the LiDAR and now do the DEM. And you can see different ways to represent the surface. Some are better than the others. And so LiDAR huge file. I mean, LiDAR, not something in which at first you're going to be able to just, send it out to the public and say, hey, look at the elevation change across campus. It's something which you have to work with. You have to choose the data. You have to figure out, okay, do I want the ground point? Do I want the top? So there's a lot more to work with there. Finally, the last thing that I asked the GIS to do in this video on surface representation across IUPUI's campus is I asked it to turn this LiDAR data into a triangulated irregular network. So essentially what that means is what it's going to do is it's going to take certain points that it deems to be important points that maybe show the corners of buildings. That represents change. So places in which there's change are going to see points being used that are then critical for then creating the triangles, so that now what we can do is, instead of seeing individual points and places in which we see gaps, we're going to create a smooth surface. Well, not really smooth, but we're going to create a surface across all this particular area in which it's covered by one of these individual triangles. Now, to keep it simple, what I did was I asked the GIS, I said, okay, when you convert the LAS points, that LiDAR data, and you choose certain ones to create this 10 feature, which you can now see, do it with about 10% of the data. Just don't do it with all of it. Why? Because it just would bog my computer down. I don't have the internet strength. I don't have the laptop strength. But if I want to increase the resolution, you can see here, I mean, this isn't perfect. I mean, you can nonetheless, though, see the air conditioning units that are on top of Kavanaugh Hall. You can still, though, get a little bit more surface undulation and understand the surface change a whole lot more than you could with the digital elevation model. So what I'll do here is I'll kind of zoom out, and now you can see once again the idea. And so what this is doing is it's creating those triangles, so a huge amount of data. But keeping with the same theme of this yellow being higher elevation, purple being lower, now we can see the building footprints very clearly using this triangulated irregular network. And so this is something you're going to see more of, especially, as I've said, with 3D technology taking off. But LiDAR and the use of triangulated irregular networks, where is it most advantageous? It's most advantageous in places in which you have high change in the surface. And so in this case, the downtown skyscrapers. You got the tall buildings that are obviously, numerous stories up in the air. And so that's obviously going to be a dramatic change from the surface down below. And so you can clearly see the tall structures. The triangulated irregular network is very, very clearly seen here in these areas where we have greater surface change. Other areas we're going to see that play out, mountainous areas, rugged topography, hilly areas. The triangulated irregular network does a good job of showcasing change. However, flat areas, let's go to the White River. Flat areas struggles with. So the flat areas, you can kind of see how you create this kind of these wonky patterns here in which you got to do a lot of editing. So flat areas, TIN, the triangulated irregular network, doesn't really handle as well. You can kind of see over here these kind of these bizarre looking triangles through here. All this would require a lot of editing on my part to create a smoother, realistic flat surface through here.